The internet is absolutely buzzing right now. Just a little while ago, Musk was casually chatting about AI robots. Now, he's revealing what seems like an earth-shattering move in the global car market. The 2026 Tesla Starlink Model 2 isn't just arriving for the masses. It's currently sitting in Tesla's most secure testing facility, having undergone the past 18 months solving 5 seemingly impossible challenges. Musk's statement captures it perfectly. I just think about making the product as perfect as possible. What we want to achieve is the ideal of the perfect product, and as long as you focus on that, you'll have a compelling product. Could this statement hint at the features of the upcoming Starlink Model 2? We've been flooded with responses from viewers who are eager for this new model to arrive. But we assure you, your wait will be worth it. Here's an unbelievable first look to make the wait worthwhile. Subscribe and turn on the notification bell as we dive into all the details in today's video. We're racing towards 75,518 subscribers and growing fast. How will the 2026 Tesla Model 2 feature polygonal energy-absorbing panels inspired by Cybertruck angles? Here's the surprise that Tesla's engineering team accidentally confirmed during internal testing. The 2026 Model 2 isn't just borrowing Cybertruck's looks. It's built on what they're calling the Cybertruck DNA revolution. Leaked CD files reveal 47 individual polygonal sections, carefully placed across the entire body of the vehicle. Each is designed to deflect impact forces at precise 23.7 degrees angles that reduce crash energy by an extraordinary 73%. This is real physics at work, backed by Tesla's genius in using 301 stainless steel polygons, just like the Cybertruck, but cleverly formed into smaller 6.2 centimeter sections. The result is a protective shell that's unlike anything the car industry has ever seen. The weight advantage alone challenges traditional thinking. While conventional cars use bulky crumple zones, Tesla's polygonal design eliminates that need, saving 340 kilograms compared to traditional vehicles while increasing safety. The impact safety this polygonal design offers makes traditional car safety look outdated. Tesla's internal crash test data shows that these polygons spread impact forces across 12 structural points, compared to just 3 in regular cars, creating what engineers call deflection channels that reduce side impact damage by 68%. But here's where it gets completely insane. The polygonal roof maintains full cabin integrity under 4.2 times the vehicle's weight, making rollover incidents virtually impossible and preventing cabin collapse. Preliminary projections from IHS suggest this could reduce severe injury claims by as much as 89%. Several insurance companies are already reviewing this for potential policy adjustments. This also explains why Tesla has been so secretive about these developments. This kind of safety innovation not only saves lives, it completely changes what's possible in affordable vehicle protection. The visual impact and aerodynamic leap achieved through these polygonal shapes show this technology is already ready for production and represents Tesla's greatest manufacturing advancement since the Model S. These polygonal panels give the Model 2 a drag coefficient of 0.19, outperforming the Model 3 and even the Porsche Taycan. Achieving this took Tesla's use of SpaceX's orbital welding, which delivers precision to within 0.03 mm per panel, reducing air turbulence across the body. Plus, it's more cost-efficient. The polygonal stamping process costs 56% less than traditional curb molds. And with 23 distinct polygonal shapes across the body, light bounces off the car in every direction, creating a visual depth that no curved EV can replicate. Imagine an EV under $11,975 with Cybertruck-grade panels and a drag coefficient of 0.19. Leave a comment with Tesla Model 2 if you think this design will change the way small cars are built forever. And if the polygonal body already feels like a miracle, wait until you hear what's underneath it. How will the Gen 3 Tesla platform cut production costs by 37% while boosting structural strength by 50%? Here's the breakthrough in manufacturing that experts said was impossible until leaked Gen 3 documents hit the internet 3 weeks ago. A single 8,900 pounds aluminum casting replaces 247 individual structural components while doing something that defies conventional engineering logic. The Gen 3 platform delivers 67,000 pounds per square inch in tensile strength compared to Gen 2's 44,800 pounds per square inch. Tesla has literally made their cars 50% stronger while cutting their weight by 36%, now weighing just 2,340 pounds compared to traditional platforms, which weigh 3,670 pounds. This is a total reimagining of how vehicles are constructed. Material cost savings plummet from $9,200 for multi-component assembly to just $3,400 per vehicle thanks to revolutionary aluminum casting techniques Tesla initially developed for SpaceX rockets. To put it simply, Tesla has achieved better performance, superior strength, and dramatically reduced costs with a single engineering breakthrough that every other automaker said was impossible. The manufacturing time saved by the Gen 3 architecture completely disrupts traditional automotive production schedules. Now, full Gen 3 platform assembly takes just 47 minutes, versus the 8 hours and 23 minutes it takes to build a conventional platform, with only 23 workers compared to 345 workers required for traditional assembly. Tesla also uses 34% less factory floor space. But here's the shocking part. The single-piece casting removes 156 potential failure points from welded joints, ensuring quality consistency at a level traditional manufacturers simply cannot match, no matter their investment. This production revolution allows Tesla to build vehicles with the luxury structural integrity of high-end cars, but at mass market prices, totally transforming what's possible in automotive economics. And it all stems from the same design philosophy that Tesla applies to the Pi tablet's unified construction. The structural advantages gained by the Gen 3 platform integration reveal the very same technological DNA that links Tesla's vehicle development to the Pi tablet's revolutionary design. Torsional rigidity has soared to 23,400 Newton-meters per degree, compared to just 15,600 for traditional platforms. Meanwhile, integrated construction reduces cabin vibration by 67% compared to multi-piece designs, using the same approach Tesla applies across their entire product ecosystem. The single-piece structure also spreads impact forces across the entire 156-inch wheelbase and integrates cooling channels that lower battery temperature by 23 degrees Fahrenheit. All of this is a testament to Tesla's mastery in thermal management. Economic analysis shows the Gen 3 platform costs just $4,200 to manufacture, down from $6,700 for Gen 2, with an initial $890 million tooling investment recouped after just 340,000 units, compared to 670,000 units required for traditional tooling. After 150,000 miles, the Gen 3 platform still retains 89% of its original value, requiring 73% fewer service intervals than conventional platforms. This integrated design approach mirrors the cutting-edge thinking behind Tesla's Pi tablet. Can a car that's 36% lighter, 50% stronger, and 37% cheaper to build really be sold to you for just a fraction of its real value? If your jaw is on the floor, drop the word game-changing in the comments. The connection between the Gen 3 platform engineering and the Pi tablet is clear proof that Tesla's design revolution spans every product they create. And the next segment proves how their hydro-adaptive suspension system confirms this unified approach is about to transform not just cars, but every device Tesla designs. How will the hydroadaptive suspension reduce spinal shock by 42% for older drivers? The hydroadaptive suspension system in the 2026 Tesla Model 2 is a medical-grade breakthrough, engineered with the precision of aerospace hydraulics and the empathy of a healthcare device. At its heart, there are 4 independent hydraulic actuators, each capable of delivering up to 2,340 pounds of force with an astonishing 0.003-second response time. The system operates with a fluid pressure of 3,400 pounds per square inch and is guided by 23 real-time sensors, with adaptive damping that recalibrates 1,200 times per second. In essence, the Model 2 reacts to the road faster than human reflexes. This is especially beneficial for older drivers. For seniors who suffer from back pain, joint issues, or osteoporosis, this system provides real protection. The Model 2 limits vertical acceleration to just 0.3 g, compared to the jarring 0. A g-force typical in traditional suspensions. It uses laser-based road scanning to detect surface irregularities up to 67 feet ahead, preparing the chassis to absorb bumps before the tires even reach them. Additionally, this data synchronizes with the lumbar support inside the seat to ensure the spine stays properly aligned during the drive. Over long distances, the system eliminates 89% of road vibrations, which are a primary cause of spinal degradation and fatigue for drivers over the age of 60. And it doesn't stop at comfort. The system also features age-specific medical integration. An osteoporosis mode softens ride dynamics by 67%, while an arthritis mode reduces sharp suspension movements that could cause joint pain. The system even helps with balance and stability, reducing the risk of sudden shifts that could lead to falls or disorientation. With zero maintenance for up to 340,000 miles, plus a backup failsafe and predictive diagnostics, Tesla is quietly solving real problems that millions of people face every day. This hydroadaptive technology is part of the same engineering revolution that powers Tesla's modular Pi tablet ecosystem, where comfort, health, and autonomy are designed to work together. How does Tesla's 2.0 battery-to-chassis architecture add 22% torsional rigidity? Tesla's 2.0 battery-to-chassis design is incredibly efficient. Rather than treating the battery as